So today, we're going to start AD looking at matrix multiplication. So this is different than the scalar multiplication that we did last time, in that we're not multiplying a matrix by a single number. Instead, what we're doing is we're multiplying one matrix times another matrix. And that isn't always even possible. Okay? So we're multiplying a matrix times another matrix. And the mathematics behind it is very easy. We're going to be using multiplication and addition. But you've got to slow yourself down and pay attention to when you're going to do which piece of that. Also remember that anytime you see two letters side by side like that, that always indicates multiplication. So you'll see the directions just give A, B like this. Literally that means A times B. So you'd multiply matrix A by matrix B. So think back to some of the algebraic notation that you've seen in the past. Your first step is that you need to determine the order of both matrices. Because the order of the matrices is going to determine if you can multiply them or not. Okay? So, for example, you might have a matrix that's 2 by 3 and another matrix that's 3 by 1. So you need the order of each one. And it's helpful if you go ahead and write them out like I've done here. Because what we need to do is we need to compare these two middle numbers. Those two middle numbers must be identical. Okay? So, and remember that's row then column. So the columns from the first matrix and rows from the second matrix must match. So once you find the order of them, just if you put them side by side like that, it's easy to check that those two numbers are exactly the same. Again, remember, rows always first, then columns. And if you look at the outer numbers, that will tell you the order of the answer. So in this particular case, the outer numbers are 2 and 1. So that tells me that the matrix that I get as my answer is going to be a 2 by 1 matrix. So not only are we changing the numbers inside, we're literally going to be changing the order of the matrix in most cases. So it's not even a 2 by 3 or a 3 by 1. The completed answer is going to be a 2 by 1 matrix. Okay? So you've got to be really careful about keeping the steps in order. Once you've done that, then it's a matter of starting the multiplication. So to begin the multiplication, what you're going to do is you're going to start with row 1 from the first matrix. Now remember, rows go across. And you're going to multiply that times column 1 in the second matrix. So it's going to be rows times columns. And that's why the number of rows from the columns in the first one and rows in the second one have to match. All right? So we've got rows and columns. And when you're doing that, you need to add the products. Remember, product is simply the answer you get when you do multiplication. So the numbers that you get when you do that, you're going to add. Now, you're going to be multiplying. The things that you're going to be multiplying is you're going to be multiplying the corresponding numbers. So pay attention to their placement. So for example, if this is matrix A and this is matrix B and I'm multiplying these together, if this is row 1, then this is the number in the first position. So remember we had the little, so from matrix A, this would be 1, 1. Do you remember when we wrote those out? From matrix B, this would be B, 1, 1. So we'd have A, 1, 2. I don't think they even put a comma between them. So this would be B, 1, 2. Remember those location markers that we used before? So this row A, so A11 would be multiplied times B11. Now this one would be B21. So this one would be multiplied by that one. So the first term in the row would be multiplied by the first term in the column. The second term in the row would be multiplied by the second term in the column. All right, so every term from the first row times every term in the first column. Then, remember that you're going to take those products, those things you get to multiply together, and you're going to then add them together. Okay? And we'll look at plenty of examples. Then you're going to repeat with every column from the second matrix. So for example, then I would still be using the first row, and I would take it times this term, and then times that term. Okay? So the first term in the first row, the first term in the first row times the first term in the second column, because we've already used the first column up. Then you'll just move on. Okay? Now, we're going to write these out so that you see every piece of it as you go. So we're going to be writing out the work just like we did when we added or subtracted or multiplied those earlier ones. Okay? Once you've multiplied all of those, every column in the second one times the first row, then you're simply going to move on to the second row. Etc. Right? And once you've done all the rows times all the columns, then you can do the mathematics behind it and simplify those and get your answer. Examples, because it's really easy if you see the pattern, but the pattern is completely different than anything you've ever done before. So you've got to pay close attention, or this is not going to make any sense. So let's just look at a quick example. I'm just going to make something up. Say I'm going to multiply these two matrices. Okay. Say I just have 1, 2, and 3, 4, and I have 5 and 6. The first thing I need to do is find out if I can multiply them together. And to do that, I just need to find the order of each one. Well, this one has how many rows? Two rows, okay, and 2 columns. So it's a 2 by 2. This one has 2 rows and 1 column. I'm going to be comparing these numbers on the inside, and since they're both 2s, that means I can multiply these two things together. And when I do, I expect a 2 by 1 matrix as my answer. Use the outer numbers to tell you what the order of the completed matrix multiplication is going to be. So now we'll just start the multiplication. So just draw a big matrix because you're going to have all your working in there, all the multiplication and the addition you'll show, then you'll do it. All right, so first we're going to start with row 1. So we're going to use the row 1, and this one only has 1 column, so we're going to be multiplying it times everything in that column. Starting with the number in the first position, which is the 1, times the number in the first number in the column, which is the 5. So we have 1 times 5. Since we have more multiplication to do with that row and that column, we'll put a plus and move to the second digit. So that's a 2 times the 6 is our next one.
So why do 6? Isn't that
Remember, it's row times column. Right? Not row times row, but row times column. Now, I didn't really need this to be that big because there's only one row here, so it's going to be it's only going to come up with one row. Only one column there, so it's only going to come up with one column as an answer, so I really didn't need that much space. All right? Now, so I'm done with row 1 because there was only one column to use. And we'll look at an example of when there's more than one column in a minute. Now I'm going to just drop down to row 2. So I'll take the first in row 2 times the first in the column. So that's 3 times the 5. Plus, take the second digit times the second digit. So 4 times 6. Okay. All right, now that I have it all written out, what we'll do is we'll start doing the operations. And notice that I left some space here, and there's a little line here. That's because you can do some of it there, and then you only have to write your answer down in a moment. So look what I mean. 1 times 5 gives me 5. 2 times 6 is 12. And 5 plus 12 is 17. Okay? 3 times 5 is 15. 4 times 6 is 24. Adding those together, you're going to get 39. And that is your completed matrix. And again, it has 2 rows and 1 column, just as predicted from the original order of the problems. Okay? Say, for example, we have 2, 3, 4, 5 times -2, -1, 4, -3. Doesn't really matter. We need to first determine the order of them. They're both square matrices. They're both 2 by 2. So these middle numbers match, so that means we can multiply them together. And this time, the two end numbers are 2 by 2, which means that we're going to end up with the same size matrix as we started with. And that always happens when you have square matrices, if the matrices are the same size. But don't anticipate it being the same, being true. All right? Now, so here's our first row. Here's our first column. Remember, it's row times column. Yeah? So.
Did you do one for the next column?
Not yet. Well, after that, yeah. So 2 times -2 is our first math. 2 times -2.
And then you add all of them. Never mind.
Plus, now we got to do the second digits, right? So 3 times 4 is next. Okay. Now we're done with that row 1 times column 1, but this one has a second column as well. So we have to take row 1. So we took row 1 times column 1. Now we're going to take row 1 times column 2. Okay? So again, same thing. First position in row 1 times first number in column 2. Leave a little space because those things all came from the same multiplication, so they go together. We're going to add those together. But these are a new column, so we're going to just leave a little space. 2 times -1 plus, then you get 3 times -3. Right? It's all right. All right. Now, we've used row 1 times both of our columns, so now we'll start with row 2. So we'll take row 2 times column 1. So 4 times -2 is our first operation, plus 5 times positive 4. Now we're done with column 1. We're never going to use it again. But we still have to take row 2 times column 2. So 4 times -1 plus 5 times -3. And this is our intermediate matrix with all the working in it. And now we'll just go back and do the math. 2 times -2 is -4. 3 times 4 is 12. And -4 plus 12 is positive 8. 4 times negative 2 is negative 8. 5 times 4 is 20. 20 minus 8 gives you 12. Here we're going to get negative 2 and negative 9, which will combine to make negative 11. Negative 4, negative 15, which will combine to make negative 19. And that's your finished matrix, which we know is going, we expect it to be a 2 by 2 matrix from our original. Okay. All right. The only other thing that you're going to see is you're going to be raising a matrix to a power that works exactly like working with any other power, but we can't just raise everything inside to the third power. You have to use the matrix operations. So that literally means just take the matrix and multiply it times itself 3 times. Now to do that, you would simply multiply these two together, get an answer, and then multiply that answer times the third one. You can't take any shortcuts. You have to just do the multiplication over and over to make it work. Okay? But that's what the power on a matrix is going to look like. So you're going to see some of those. You could also see problems where it says 5a times b. Again, what does it mean to have that number in front? It means to multiply. Exactly. So you're going to have to do 5 times matrix A, and then you'll multiply that answer times matrix B. So you can still have some scalar multiplication in there as well. Remember, if you have 5A, that just means multiply everything inside that matrix by 5. The scalar multiplication we did last time. Okay? All right. The homework for this, 1, A, B, C, E, H. Oops, sorry. 4, A and C, 9, and 12.